Now in example 4, we're going to use the rational functions to follow the following questions, and then we're going to end up graphing. If you notice, A through E wants factored form, lowest term, domain, whole, and vertical asymptote. That's what we did in the first video when we found domain, wholes, and vertical asymptotes. F and G want to know, are there any horizontal or oblique? That's what we did in the second one, where we found horizontal or oblique, comparing these 4 cases and comparing our N and M. H and I want our X and Y intercepts, which we did last video, and then we're going to graph all of these together. So if you are not comfortable with those first 3 videos, you need to go back and rewatch them, because now we're doing it all together. So because A through E are these right here, I'm going to do these in this order here. So the first thing we need to do is factor. So my factored form here, since this is an easy trinomial, I need to find out what multiplies to my A times C, which is 1 times -5, and what adds up to my B, and that's going to be X minus 5 and X plus 1. Over, we have a difference of squares here. The square root of X is, or X squared is X. The square root of 25 is 5. So we have X plus 5, X minus 5. Okay, now I'm actually going to jump down here to E because it says find the domain. Before you simplify, set the denominator to not equal 0. So my denominator here, X plus 5, X minus 5 to not equal 0, which means here we get that X cannot equal -5, and here we get that X cannot equal 5. So what is my domain? My domain is the set of all X such that X cannot equal plus or minus 5. Okay, now we're going to simplify and write this in the lowest terms. So what cancels here? We have an X minus 5 on top and bottom, so that leaves X plus 1 on the top over X plus 5 in the bottom. Now that we have simplified and wrote in lowest terms, which is this, find the wholes. Anything that canceled leaves behind a hole, and we will find the coordinates by evaluating R of X in lowest terms. So here, we get that we have a hole when X equals 5. So now plug that into your function in lowest terms. So I've got Y equals 5 plus 1 over 5 plus 5, which is going to give me 6 over 10, which is 3 over 5. So we have a hole at the ordered pair of 5 comma 3 over 5. Now I'm going to start putting these on my graph as I find them. So I'm going to put this hole in my graph here. So we're at 5 3/5, which isn't quite 1. So I'm just going to do it somewhere right here. Now I can tell very clearly that that is a hole, but if on your test, on your attendance quiz, if I cannot tell that, it might be a good idea for you to write a note in there that, hey, that is a hole, so I don't count off. So if it is not clear, or you want to just make sure I know and I can see that, tell me that that is a hole. Okay. So then Lastly, for this part, vertical asymptotes. Oops, wrong paper. Vertical asymptotes, once in lowest term, set the denominator to equal 0. So we're going to take this denominator here, set it to equal 0, and we get x equals -5. We'll have a vertical asymptote at x equals -5. So now let's put this on our graph. I'm going to go to where x equals -5. And here is my vertical asymptote. And it does say to label it. So I'm going to come down here and label this as x equals -5. Okay, so reviewing this one more time, my domain is made up of these two things here. Why can x not equal +5? Because at +5, I have a hole. Why can x not equal -5? Because at x equals -5, I have a vertical asymptote. So now F and G want to know if I have any horizontal or an oblique asymptotes. Ooh, okay. So to do both of these, we need to compare N and M. And really, if I answer one, I'm answering both. If I have a horizontal, I can't have an oblique, and vice versa. If I have an oblique, then I can't have a horizontal. It's one or the other. So let's compare our N and our M. And it doesn't matter if you do the original or the reduced. If I do the original here, my N is 2 and my M is also 2. If I do my reduced, then my N is 1 and my M is 1. Either way, they're going to be equal, either 1 and 1 or 2 and 2. And when these are equal, we have a case number what? When the numerator is equal to the denominator, my horizontal asymptote is the ratio of the leading coefficients. So you either have 1/1 or 1/1. Either way, we get a horizontal asymptote at y equals 1. So I'm going to come back down here to my graph, and where my y is negative or is at 1, I will graph this. Here's my horizontal asymptote at y equals 1. We're labeling asymptotes. So are there any oblique? Oblique would have been if I would have had a case 4. So no. And again, it can't be both of these. It's either horizontal or oblique, or it can be none, but it can't be both. So now x and y intercepts. Okay, x-intercepts occur where the numerator is 0, but it does go on to say, which is the first time it's been applicable, the x-intercept are the real zeros of the numerator written in lowest terms. So I don't want to use this right here. And your clue would have been, if I say I have an x-intercept at 5, nope, I have a hole right here at 5. So that can't be true. So you're wanting to do this in lowest terms here. So we have x plus 1 equals 0, which means x equals -1. So wrote as an ordered pair because of this is the same form as a vertical asymptote. It's hard to tell the difference. So -1, 0. Here's my x-intercept. And then y-intercepts, plug in a 0 for x and simplify to get your y. So you can do this in either one. It doesn't matter which. Lowest terms is going to be the easiest. So I've got y equals 0 plus 1 over 0 plus 5. So we get 1/5. So we have a y-intercept at 0, 1/5. So right there. So now let's graph it. Well, I can see how this section down here is going to look. I know these are going to connect. They're going to get closer and closer to that vertical asymptote. And then it's going to come over here and connect to that hole, but not go through it, go around it. And it's going to get closer and closer to this vertical or this horizontal asymptote. So now I don't know what's happening on the left side of this vertical asymptote. I know nothing can happen up here because if something happens up here, then it's not going to pass that vertical line test and it won't be a function. I know it's a function. So it's either going to be up here in this portion or down here in this portion. So let's use our graphing calculator to find it out. So, okay. My daughter was playing with my calculator. So let's clear all that out. Okay, let's go to y equals, and give me a second. We were playing around. Okay. And for y1, I am going to put my original function here. And to do that, I want to put it in as a fraction. It makes it a little bit easier. So I'm going to go alpha y equals, green button, alpha y equals, and that first one n over d. Now I can write it as a fraction. So I have x squared minus 4x plus 5 in the numerator. And that doesn't look like an x squared, does it? X squared. There we go. And then in the denominator, we have x squared minus 25. I want my graph to match this graph here. So negative 10 to 10 and negative 10 to 10 on my x and y is my standard graph right here. So I'm going to go to zoom 6. And here's my graph. Now, we already have this portion right here and this little portion here. So now we need this portion up here in this top part. As you can see on this graphing calculator, we are putting in these dashed lines for that horizontal and vertical asymptotes. They are not here, right? We're putting them in as dashed lines because they don't actually exist. They help us guide our graph because we know it's going to approach those asymptotes and not touch them. So we need to be able to find those on our own. So we'll put this in here, and you can, when it's on your test or when it's on your attendance quiz, I don't really care. If you just want to make a rough sketch of just some kind of U right here, then I'm fine with that. You can also go in here to this table and find some more values here. So we can plot right here, negative 6, 5. 5. We have negative 7, 3. And negative 9, 2. And so with those extra 3 points, I can draw this pretty accurate, knowing it's going to connect and get closer to those asymptotes. So we got this from our calculator. Okay, so there is my graph. Now, before I end this video, I said you can't see this when you're looking at the graph, but you can see a lot of this stuff right here from this table. Okay, I have a hole at 5. If I go to x equals 5, I do get an error because that value doesn't exist. If I go to -5, I get another error. So on your calculator, you can't really see the difference on error. It doesn't say error vertical asymptote and down there error whole. But I can see I do get an error on these because I am showing that that domain does not happen at x equals plus or minus 5. So you can't tell the difference, but you can check that that should be right. You have a vertical asymptote at 1. I don't know if this will show as well with these fractions. But you can see these fractions here, those numbers are getting closer and closer to 1. Okay. As those numbers get closer and closer to each other, that means it's getting closer and closer to 1. Then I can see my x-intercept here. At x equals -1, we have -1, 0, so that's my x-intercept. And I can see right here below it, my y-intercept is at 0, 1/5. So you can even see your x and your y-intercepts as well. So you can see a lot of these values of a lot of these things looking at that table, so use that table to your advantage.